Welcome back to the Deep Dive, where we take on the topics shaping tomorrow, strip away all the jargon, and deliver the insights you really need.
All custom tailored for you.
Our mission today is pretty laser-focused. We're diving deep into the 8 most crucial AI trends projected for 2026.
Yeah, we've been digging through a lot of sources on this. Research reports, white papers on quantum, on agentic AI.
All to really map out the trajectory. We want you to grasp not just what is happening, but, why it matters this year specifically.
Right.
Okay, let's unpack this. We've organized these 8 shifts into 2 major categories. The first 4 are all about the practical deployment of AI, how it's changing, what it does, who it works with, and how it's moving from digital into the physical world.
And that shift is just fundamental. I mean, the story has moved beyond these singular monolithic models trying to do everything.
Okay.
Now the whole emphasis is on specialized collaboration, on systemic coordination.
Let's jump straight into that collaboration then. Trend number 1, multi-agent orchestration. We spent, all of 2025 talking about the single AI agent, right?
The one that could reason, plan, take action. The autonomous one.
Exactly. They proved the concept, but the reality is no single agent truly excels at everything. They get error-prone when things get too complex.
And what's fascinating is how fast the industry realized it needed specialization. It's really mirroring how human teams work.
How so?
Well, if a single agent tries to write code, call an API, and debate strategy all at once, the quality just tanks. To get reliability and scale complexity, you need a team.
So the single agent is out and the collaborative team is in. What does that team actually look like? Who's managing it all?
The key component is the orchestrator. You can think of it as the project manager.
Okay.
It's the coordinating layer that takes the initial goal, say launch a new marketing campaign, and then delegates all the subtasks to specialized components.
And those components are the agents with specific jobs, I'm guessing.
Exactly right. You have a planner agent, and its sole job is decomposition.
Just breaking it down.
Just breaking that massive goal into tiny, achievable steps. Step 1, research keywords. Step 2, draft ad copy. Then you have the worker agents who are specialists in those tasks.
So one writes code, one generates images.
One calls an external API to query data. But the really critical addition here is the critic agent.
A critic agent. What did that do?
Its only role is oversight. It evaluates everything the worker agents do, and it evaluates the planner's strategy. It flags issues, factual errors, hallucinations, maybe just not following the style guide.
So this is where the reliability really skyrockets. The critic and the orchestrator, they bake in a mechanism for cross-checking.
Yeah.
You're not just hoping one AI gets it right.
You're introducing friction and verification, and that's essential for any high-value workflow.
That structural approach leads us right into trend number 2, the digital labor workforce.
Yeah.
We take those coordinated agents and we operationalize them. They become these autonomous digital workers running entire workflows.
And this trend is all about defining these teams not just as a technology, but as a resource. It starts when a human user defines a task using multimodal input.
So speaking of request, maybe showing a screenshot of a spreadsheet.
And a handwritten note on a whiteboard, all at once. The agent team interprets all of it, develops a plan, executes, and then, this is the critical part, integrates the final output into existing systems.
It's not just generating text, it's updating the CRM, filing a report in the finance system.
Or kicking off a code deployment. And this is where we have to talk about control.
Right.
These autonomous systems are fundamentally enhanced by human-in-the-loop AI. And this isn't just a checkbox. This is the safety apparatus.
The human provides oversight, correction.
And most importantly, strategic guidance.
The rails, as we call them. The human makes sure the agents are not just getting the job done, but getting it done in line with company values or legal rules.
Precisely. You automate the execution, but reserve the strategy for the human. And that's where you see the force multiplying effect.
Instead of spending 8 hours on tasks, a knowledge worker might spend 30 minutes giving directions to 8 digital workers.
And that's a massive, massive scale benefit.
Okay, now here's where it gets really interesting. Trend number 3 is physical AI. For years, we've had our AIs in separate boxes, right? LLMs generate text, diffusion models generate pixels, all digital.
All in the digital space.
Physical AI is about closing that loop,
Yeah.
having models that understand and interact with the real messy 3D world.
That's the key. We're talking about models that don't just generate things, but perceive, reason about actual physics, gravity, friction, and then take sophisticated physical action through robotics.
Historically, getting a robot to do anything useful meant just painstaking programming.
Oh, thousands of if-then rules. If temperature is X, grasp with Y force. It just breaks down immediately in the real world.
So what's the shift?
The shift is entirely toward training and simulation. Models are trained in these massive virtual worlds that accurately simulate physics. They learn implicitly how to grasp something without crushing it.
So they're learning to perform actions, not just follow rules.
Exactly. And the sources call these world foundation models. They're generative models that understand 3D environments. They can actually predict future physical scenes, allowing a robot to plan its next moves.
Let me challenge that a bit, though. We've heard the robot revolution is coming for years. If they're only trained in clean simulation, what happens when a real robot in a warehouse finds something that's, I don't know, wet or dusty? Isn't that a huge point of failure?
That is the central hurdle, absolutely. But the ability of these world models to generalize is just accelerating exponentially. The sources are pointing to 2026 as the year these models take humanoid robots from pure research right into commercial production.
Really, commercial production?
Especially in logistics and advanced manufacturing. Because they are trained on generalized physics, they are just far more adaptable than their old programmed predecessors. We're seeing mass production scaling up now.
Okay, that makes sense.
And this takes us pretty smoothly into trend number 4, which is social computing. Because once you have all these reliable physical workers, you can't have them acting like isolated islands. Social computing is about creating a shared AI fabric where many agents, physical, digital, and human, all operate together.
So we're moving beyond a small team of 5 agents to a whole networked ecosystem of hundreds, maybe thousands of agents and robots.
Exactly. Think of it less like a team and more like a shared nervous system for a whole company. Information flows seamlessly. Agents can exchange context. They can gather intent from each other and from the humans around them.
Give me an example of that.
Okay, so one agent might see a sudden backlog in manufacturing. That's the physical AI. And instantaneously, the supply chain agent, the digital labor, begins modeling disruption scenarios and proactively adjusting orders, all without a human having to step in.
So that seamless exchange of context, the agent understanding the intent of another agent's action, that creates something pretty powerful.
The sources describe it as collective intelligence or even real-world swarm computing.
The whole network becomes responsive.
The whole network, dynamically optimizing an entire system, whether that's a data center or a factory floor.
That's a powerful picture. But none of that orchestration is possible without a revolution in the computational backbone and a solid framework for accountability.
Right.
So if the first half was what AI does, the second half is how we build it and who governs it. Let's start with governance.
Trend number 5, verifiable AI. And this is fundamentally driven by regulations, specifically the EU AI Act.
Which becomes fully applicable by mid-2026.
Yeah. And it's not just for Europe, like GDPR did for data privacy. This is effectively setting the global template for AI governance.
And the core idea is that AI systems, especially high-risk ones,
anything affecting health, safety, access to services,
must be auditable and traceable. The era of the true AI black box is over.
It's done.
But let me ask you,
Yeah.
Doesn't regulation like this, especially something so complex, run the risk of stifling innovation? Does it just slow everything down?
That's the tension, for sure. But the market needs trust. The sources suggest that instead of stifling innovation, this is actually forcing the industry toward maturity. It's shifting AI from move fast and break things into a reliable service.
So what does it actually mandate?
It breaks down into 3 main pillars. First, documentation. Technical docs showing the system's design, testing, risks, the whole audit trail.
Okay.
Second is transparency. Users must always know when they're interacting with a machine. Any synthetic, content, text, video has to be labeled as machine-generated.
And the third pillar, data lineage. That's huge for creative industries, right?
It is. It means you have to be able to summarize where your training data came from and, crucially, prove your respected copyright opt-outs. The onus is on the developer to prove they didn't train on data they weren't supposed to.
That's the new global standard.
Okay.
That's the trust foundation. Now for the infrastructure revolution. Trend number 6. Quantum utility everywhere.
Right.
This is the one that the source said changes everything, but also changes nothing.
It changes nothing because, no, you won't be running a quantum processing unit, a QPU, in your laptop anytime soon.
Classical computing isn't going away.
Not at all. But it changes everything because 2026 is when we reach quantum utility scale. That's the point where quantum systems can reliably solve real-world problems better, faster, or more efficiently than our best supercomputers.
So the keywords there are reliability and outperformance on specific tasks.
Yes, and the key model is the hybrid quantum classical era. The QPU isn't replacing the CPU, it's becoming a specialized accelerator woven into the existing infrastructure.
So when a normal workflow hits a calculation that would take a classical computer, say, 10 years,
That task just gets automatically routed to the quantum coprocessor. It's like a highly specialized turbocharger.
and what are the big tasks that suddenly become possible?
Three main categories. Optimization, so think logistics or supply chain routing, simulation, especially for new materials and chemical reactions, and decision-making under uncertainty.
Problems that were just out of reach before.
And now they become mainstream business tasks.
That integration needs speed, which brings us to trend 7, reasoning at the edge. We know small models, just a few billion parameters, can run on your phone. But in 2026, those small models start to truly think locally.
That's right. Today's big frontier models, when they do their best work, they use what's called inference time compute. They spend extra time thinking step by step before giving an answer.
And that thinking process requires massive cloud resources.
Usually. But here's the game changer. Teams have figured out how to distill all of that high-fidelity, step-by-step reasoning from the massive models and use it to train the smaller, local ones.
How does that work?
Well, think of the massive model as a master chef who documents every single thought process for a complex recipe. The small model is the apprentice. We just transfer the master's entire logic chain to the apprentice. The apprentice doesn't need to learn the theory, it just mimics the master's reasoning path with way fewer parameters.
This distillation means you get sophisticated reasoning models that work efficiently, locally. Why is that local factor such a big deal?
Three huge benefits. One, they work offline. Connectivity is irrelevant.
Okay.
Two, your sensitive data never leaves the device. That's a massive privacy uplift. And three, they eliminate round-trip latency. No more waiting for a response from the data center.
For anything real-time, robotics, self-driving, that's a fundamental requirement.
It is.
And that local thinking sets up our final trend, number 8, amorphous hybrid computing.
The ultimate infrastructure goal, a truly fluid computing backbone that seamlessly blends AI model types and the underlying hardware.
What do you mean by blending?
Well, on the architecture side, models are moving beyond pure transformers. They're integrating things like state-space models to handle long-range data more efficiently. The model itself becomes tailored to the problem.
And the hardware is blending just as much.
Right.
Cloud computing is becoming fully differentiated, combining CPUs, GPUs, TPUs, the QPUs from our quantum trend, and even neuromorphic chips.
Right.
For listeners who haven't heard that term, what are neuromorphic chips?
They're specialized chips designed to emulate the biological structure of the brain. They process info through spikes, mimicking how neurons communicate. This makes them incredibly efficient for certain tasks, like pattern recognition, using a fraction of the power of a GPU.
So the goal of this amorphous infrastructure is to automatically map the right part of the model to the right piece of hardware.
Exactly, to the optimal compute substrate. If one part needs parallel processing, it goes to a GPU. If another needs precise optimization, it goes to a QPU. It's a unified environment for maximum performance.
And looking further out, beyond 2026, the sources even hint at things like DNA computing joining this mix,
making the backbone even more flexible and dense.
So what does this all mean for you? We've covered a massive amount of ground here. We have the emergence of this decentralized physical AI workforce, the workers, and then these underlying revolutions in quantum and edge reasoning, all held accountable by verifiable AI.
If you connect it all back, the key takeaway is convergence. The future of AI isn't about one single breakthrough. It's about recognizing that future systems will be collaborative teams of agents and robots, highly regulated, and powered by this diverse hardware backbone that uses everything from GPUs to QPUs.
These 8 trends are working together.
They're working in concert to completely redefine how work gets done. And, this raises an important question.
Go on.
The rise of reasoning at the edge means sophisticated thinking is now happening right on your device. At the same time, quantum compute is being woven into workflows, accessing sensitive data for optimization. So if thinking happens on your device and quantum systems handle the most complex calculations, how will those two trends redefine our traditional concepts of data control and security? What happens when complex thinking is no longer server-side?
That's a perfect provocative thought to end on. We've delivered the 8 trends the sources predict for 2026, but we're curious what you think is missing from this global picture. Thanks for diving up with us today.